Hello everyone, welcome back to Coding Every Day. Today is day 29. I'll be doing a graph problem today. It is February 13th, 2025 at 3:10 p.m. Today is a Thursday. Clone graph I looked at, and this one looks kind of boring. You just have to create a copy of a graph, so I'm going to try walls and gates. Today is a Valentine's Day themed episode. Tomorrow is Valentine's Day. So in the background here, you can see I have a balloon that I purchased for my fiance that I will give to her tonight at midnight. That being said, let's work on this problem here. So this is islands and treasure. So we're given a grid with different numbers. -1 is water, 0 is a treasure chest, and infinity is a land cell that can be traversed. We represent infinity with this integer. Fill each land cell with the distance to its nearest treasure chest. If a land cell cannot reach a treasure chest, then the value should remain infinity. Assume the grid can only be traversed up, down, left, or right. All right, so basically, we have a grid, and each element should be 0 a treasure chest, -1 water, or an integer that represents how many cells away it is from a treasure chest. So my idea here is for every treasure chest, we will, so let's assume this is our grid. I'm going to use the square tool because I'm learning. Okay, so here we go. So we're going to have a BFS until we, I think what I'll do is just have first I'll go through the entire thing and mark all of the treasure chests, and then I'll BFS through every treasure chest. And for every treasure chest, I will breadth first search. So if this is a treasure chest, these two will be 1, and then from all of the ones will be 2, and so on. And then let's say later on we encounter a treasure chest here. We will BFS through this treasure chest, and this we'll check this versus 1. So it's 1 away from here versus what we've already seen, and we'll pick the minimum. That's what it wants, right? To the nearest treasure chest, yeah. So we'll pick the minimum. So I think how I'm going to do it is every BFS will reset our visited set, and then we'll also have another we need to map each position to a value. I think we can just do that in place at grid. And we can say if like our current BFS distance is less than the grid distance, then we can, if it's less than whatever's at the grid now, then we can update it. I'm muted, guys, sorry. So I was saying we'll do this. So we're going to have a visited set that will reset with every breadth first search, and then we'll just adjust it in place with the grid. The actual values, the distances themselves, we'll just do in place with the grid. And then we'll BFS for every chest location. So what I was doing with my mic muted was just iterating through the entire input, and if it equals 0, I'm just getting the chest locations basically. So chest locations dot append will append the tuple, row num, column num like this. Okay, so I could probably do this in list comprehension, but it might be kind of long. All right, so obtain all chest locations in list as tuples. Chest locations. All right, so if I print that, let me just make sure this is working. And it is the integer 0, not the string 0, I believe. So here we have 0, 2, and 3, 0. So if we look 0, 2, that's correct. 0, 1, 2, 3, 0, that's correct. Okay. So now we'll have a visited set. And now we're going to basically breadth first search for every treasure chest location. So for chest in chest locations, I guess I could call a function explore chest. We will explore the chest. So with chest. So this will take in chest position. Yeah, we'll just say chest. And then this, we return the grid itself. Yeah, modify the grid in place. Okay. So explore chest is going to take in a chest and the grid, which is, we're going to be modifying the grid. So to do that, I think we have to pass in, let me see if can I say grid of 0, 0 equals test. Let's see if this works. All right. Let me see if the function is being called. Yes. Oh, I'm not printing grid or anything like that. So if I print grid, I just want to make sure it's being modified. It doesn't seem like it is. Okay, so this is not, oh, I have two equal signs. Okay, there we go. So we can modify grid from within this function, and it's probably because it's within the local scope of this function here. Okay, so we want to do a breadth first search because we're looking for the nearest things. So we'll have a deck, and I'll do it iteratively. So from collections, import deck. All right. Also, I'm going to need a bounded function, which I always do, which takes in row and column, return if 0 less than or equal to row, less than or equal to length of grid, and 0 less than or equal to column less than length of grid 0. So this will check if a row and column is bounded within the grid. Okay, so now let's just write the skeleton for a DFS here. So a queue. So chest is a position. So say like chest row, chest column. So we'll unpack this tuple. Okay, while queue. Okay, so we're going to start at the chest and then we're going to breadth first search it. So within the queue will be positions. So we're going to pop and then map it to row and column. And then we'll say, so we want to explore all 4 cardinal directions. So I usually say delta R, delta C in the 4 directions. Like this. 1, 2, 3. So left is same row -1 column. Up is -1 column, same row. Sorry. same, up one row, same column. To the right is same row plus one column, and below is plus one row, same column. So then we're going to R and C will be reassigned to the new position, or maybe I'll make it a new variable. So new R and new C like this, delta C. All right, so now these are the positions we can check. So first, so there's three things here. So water, already explored, and out of bounds. So I can just do an if statement here. So if grid of new R, actually let's check if it's bounded first. So if not bounded, new R, new C, or it's water, so grid of new R, new C equals, what was it, -1? Yeah, the integer -1, or I think I can do this, right? Or it's invisited, so new R, new C, invisited. Then, so if any of those are true, so these are all bad. So if it's not bounded, or if it's water, or if it's visited, then we'll just continue. Otherwise, we will q.append left the tuple new R, new column, and then add it to visited. So visited.add new row, new column. And then here for every chest, we want visited to be a empty set like that. Actually, well, we want this to be invisited. Like that. Okay. So after that, I want to print, let's say, grid after exploring, I guess. Yeah, grid after exploring chest. And then we'll say grid. Oh, I need to make Q a deck. All right. All right, 1 second. Okay. So let's see if this looks right. And am I modifying the grid at all? No, I'm not. I'm not modifying the grid at all. I'm just exploring it. So what do I want to do? Okay, yeah, this is correct. So I don't just want it to be positions in the queue, I also want it to be a distance. So we'll say like distance. And then here we're going to append distance +1. like that. And then we'll say grid of new row, new column equals distance plus 1. Sorry, new C like that. All right, so this, right now it's just overwriting it. All right, so let me write this example down quick and see if it's working. So the starting grid is infinity, -1, 0, infinity, 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 -1, infinity, -1, infinity, -1, 0, -1, infinity, infinity. Okay, so we start with this chest here. So it should be, I'll just copy this. So now it's going to be 1, 1, 2, 2, 3, 4, 3, 4, 4. So it should be 4, -1, 0, 4, 4, -1, 0, sorry, 4, -1, 0, 1, 4, -1, 0, 1, 3, 2, 1, -1, 3, 2, 1, -1, 4, -1, 2, -1, 4, -1, 2, -1. And this says 5, -1, 3, 4, but I have a 0. Oh, it's because it's a chest. Oh, okay, so we also have to make sure that we don't overwrite chests. So we could say if it's in -1, 0, like that. That should fix it. Yep, it fixed it. Okay. And then let's try it for the other chest. So let's label it. So this is just chest row 0, column 2. And this one is going to be chest. This is start, let's see, original. And then this is chest of 3, 0. Okay. So, and just to make sure, so the 0 is returned in the output. Yeah, okay. All right, so this one becomes 1, this one becomes 2, these become 3, this becomes 4, this becomes 5, this becomes 6, this becomes 7, and this one is still infinity. Okay. So let's see. So we have 3, -1, 0, 1. So this one is at 1. That shouldn't be possible. It's impossible to reach this. So it should still be infinity. Oh, it's because I'm just overwriting stuff. So let me just try this here. So if chest does not equal 3, 0. Continue. Okay, so 3, -1, 0, infinity, 2, 3, 4, -1, 1, -1, 5, -1, 0, -1, 6, 7. Okay, perfect. So this is working. It's just, in my mind, it's important to, before I move on to the next thing, just make sure that this is working. And then what we should expect in the final version. So this would be 1, this would be 1, this would be 2, this would be 1, this would be 2, this would be 3, this would be 2, 3, 4. So we should expect 3 negative. So this is what we should expect. So what we have to do is, okay, so update distance if if smaller. So what we want to say is if distance plus 1 is less than grid of new R new column. So if this is smaller, then we should update it. Otherwise, we should not. Is that it? And then let's get rid of this. So it says accepted. So I'm going to assume that it's the right one because that's the expected output. I have 5 here. No, it's a 3. Yeah. Okay. So let's see if I missed anything. Okay. Perfect. This reminds me of a problem I got on a take-home assessment, and I failed it, but now I would definitely be able to pass it. So I've definitely been getting a lot better, which is really exciting. Yeah, that was a pretty standard graph problem. I wonder if I'm ever going to get one where I have to build like an adjacency list, or if it's always just going to be these 2D array type things. But either way, I'm liking it, and I feel like it's useful skills here. All right, so I'm just going to comment some stuff. So return if a position is in bounds. Okay, so this is basically just a BFS, and then we'll say, yeah, update distance of smaller. Check all 4 cardinal directions. Yeah, all right. I think it's pretty good, pretty self-explanatory. Yeah, perfect. So that's day 29, I believe. Almost at 30 days in a row, which is a month, so that's great. And I'll see you guys tomorrow. Happy Valentine's Day.